Brad McCullough here. This is another video in a series of videos with regards to asset performance metrics, or better, more to the point, maintenance metrics. Today we're going to talk a little bit about downtime and that metric and why it's important and how you can think about downtime as we break it into components. But first I want to just do a quick overview of the previous video, which was really about mean time between failure. Quick overview on that purpose-driven metric. So if you remember, we talked about mean time between failure as a purpose-driven metric, right? What that means is it's a way to energize the team, give them the purpose. And mean time between failure is really the number of failures during a time period on either an asset, a line, or even the whole plant. And the purpose of the team is really to eliminate those failures, get them excited, get them energized when you look at it. And like I said, it's exciting watching the team get motivated, get excited as you improved your mean time between failure from 30 minutes to 35 to 40, and they feel like they're making progress. It can be energizing and be fun. You can make it fun as we attack the problems of the day and start to eliminate those failures. But you got to remember though, not all pieces of equipment are the same. Some of them are more important than others, and not all failures are the same. Some failures are harder to diagnose, take a lot more time to repair, a lot more parts, and impact manufacturing in a worse way. So it's real important that you have a good strategy with regards to the problems that you're going to eliminate from your proactive maintenance effort. So why is it important to look at downtime? What does downtime look like? Let's just take a quick look at a process of dealing with a down piece of equipment and see what that looks like. So first, there's a failure. Something happens in the shop floor, right? The second thing is that an operations person will take a crack at it. They'll try to fix it. They're going to try to make it better. So there's some time lost there, right? Then they're going to call maintenance, and then there's some response time. It's going to take a while for a maintenance person to get off their other job, get to the next, and respond to the problem. Then we'll go into diagnostic mode. They'll try to troubleshoot it, and depending on how good your technical team is on the floor and the types of equipment they're working on, this might be a quick diagnosis, and it might take a really long time. A lot of the customers I work with talk about the ability to troubleshoot and get the root cause quickly. It seems to be a problem, and it can be, specifically with technology becoming more and more complex. So once they diagnose it, then they go to get the part. Hence again, here's another problem. Do we have the part we need? So the logistics part becomes very important. The best maintenance team on the planet out on the floor, not supported properly from a logistics perspective, will still be ineffective. And a lot of times when the diagnostics and the parts go together, we don't do a good job troubleshooting, a lot of part swapping goes on. So what ends up happening is maybe you fix a machine, and then if you're lucky, the maintenance person takes a handful of parts back to the crib, unknown, good, not known, returns them back in. Then you're stuck with parts in the shelves wondering, should I use them again or shouldn't I? So parts are very important. Then they make the fix. Finally, we get the fix, right? And lastly, we validate it. So all the while these steps, there's 7 steps going on here, production's down. We're losing. So downstream equipment's not running. This piece of equipment's not running. People standing around, costing a lot of money, time, and parts. And oh, by the way, in the reactive mode, this getting parts, oftentimes when something fails, there's collateral damage. So this whole process is thought of as being anywhere from 5 to 7 times more costly than a proactive maintenance effort or a PM, something more proactive. So what's that look like? We already know what we're going to do. We've got a planned event to eliminate a failure that we've already identified and named. So we get the parts or materials we need. We respond. We go implement our fix or implement our PM, and we validate the fix and give it back to operation. So a lot less time and steps involved. Not to mention, we can do this off shift or when production isn't running, so it doesn't affect production whatsoever. So thinking about the pieces of this and how it impacts operations and the overall cost, you can kind of see why a reactive work order would be 5 to 7 times more expensive. Now we're also going to talk in a later video, we're going to talk about how you measure this from a maintenance labor perspective, and what some of those metrics look like and how you know if you're gaining or losing in the battle of becoming more proactive, right? So proactive work can be done in non-productive times, as I said. Anyway, quick overview of downtime, mean time between failure, purpose-driven metric. When something does fail, we track downtime, and we have these processes involved. We try to become more proactive as we move forward and target failures that eliminate plant downtime and let our production partners do the job they want to do. Hope that helps. It's a quick overview of downtime metric and how you track it, how it compares to mean time between failure, and how they go together. Any questions? Feel free to reach out to bmccully@advancedtech.com. There's my phone number, and also the YouTube channel, Asset Performance Enthusiasts, if you want to catch up on all the other videos. Thanks. I hope you have a good day. Hope this helps. Talk to you soon. Bye.